All right, when I say forensic investigation, what comes to mind? Probably a crime scene, right? Fingerprints, DNA, looking for a motive. Well, today we're going to do something a little different. We're taking all those same ideas, that same deep dive analysis, and we're applying them to a single mysterious number. Yeah, we're treating this number like a suspect, and we're going to hunt for clues, look for connections, and see what kind of hidden story it's got to tell. So let me ask you this. What if a number wasn't just a number? What if it was a key, like a Rosetta Stone that could unlock some kind of hidden order in the universe? That's really the big question we're asking today. Is it even possible for one single number to connect worlds of math that we're always told are completely separate? And this is our subject, our numerical person of interest, 28,757. I mean, look at it. On the surface, it just looks like any other number, right? But believe me, the evidence we're about to dig into, well, it suggests there's something way more profound hiding in plain sight. Okay, before we dive in, we have to talk about the elephant in the room, and that is a little thing called apophonia. It's basically our brain's tendency to see patterns in random stuff, like seeing faces in the clouds. So the whole investigation really comes down to this. Are we looking at a real, incredible discovery, or are we just connecting a bunch of random dots because our brains want to? There's only one way to find out. Let's look at the evidence. Okay, first things first, we've got to perform a kind of numerical autopsy. We're going to crack this number open and look inside to find its fundamental building blocks, its secret DNA. And boom, right away, we find our first big clue. 28757 isn't a prime number. It's something called a semi-prime. All that means is that it's the product of exactly two prime numbers, 149 times 193. You can think of these two primes as its parents, its source code. So if we want to understand our suspect, we've got to profile its parents. Okay, now this is where it starts to get really interesting. Take a look at how these two parent primes are actually built. It turns out both of them can be written as the sum of two squares. So if you look at the table, 149, that's 10 squared plus 7 squared. And what about 193? Well, that's 12 squared plus 7 squared. You see it, right? Did you catch that common element? That's right, that shared piece, 7 squared, which is 49, that is a huge piece of evidence for us. It's almost like a genetic marker that links both factors together. So you've got one built from a base of 10, the other from 12, but they are both fundamentally anchored to the number 7. This is the first real hint we have of some kind of deliberate symmetry, something that feels, well, a little too perfect to be just random chance. All right, so we've looked at the number's DNA. Now, let's figure out where it lives. Let's map its location. How does this thing fit into the huge, wider landscape of all the other numbers? To do that, we're going to use this really specific mapping system. It's called the 36er Schlüssel, which basically translates to the 36 key. And what it does is organize numbers into this cool cyclical pattern. And the way it works is actually super simple. You just take our number, 28757, and you divide it by 36. Whatever's left over, the remainder, that's its index. And that index tells you exactly which of four, let's call them cosmic arms, it belongs to. So what happens when we do it? Well, here's the result. When you divide our number by 36, you get a remainder of 29. That little piece of information places it in what's known as the arm of completion. But hang on, the plot thickens. The number 29 just so happens to be the atomic number for copper. CO on the periodic table, a key conductor of electricity and heat. So, is it just a coincidence that our number, which already seems to be connecting different mathematical ideas, lands right on the copper index? It's almost as if it's telling us it's a conductor too. In any good investigation, you don't just look at the suspect in isolation. You have to look at their associates, right? Their accomplices. So that's what we're going to do now. We're going to examine the numbers right next to 28757. Are they just random neighbors, or are they in on this mathematical plot? Okay, let's look at the prime number just below our guy, 27,599. Now, at first glance, there's nothing special there. It looks totally unrelated. But what happens if we measure the distance between them? And wow, the evidence here is just stunning. The distance is exactly 1,158. And that number is anything but random. It is exactly 6 times 193. And what's 193? It's one of our number's own prime factors, its own DNA. So this neighbor isn't just randomly sitting there. It's locked into this perfect harmonic relationship with our subject. Now the question is, no way this could happen on the other side too, right? All right, now let's check the other side. The next key number up the line is 29,651. So what about the distance this time? It's almost unbelievable. The distance is 894. And what is 894? It's exactly 6 times 149, the other prime factor. I mean, do you see what this means? 28,757 isn't just some random number. It's sitting at the dead center of a kind of mathematical force field, perfectly balanced between two neighbors whose positions are defined by multiples of its own DNA. The odds of that happening by chance, they're just astronomical. Okay, all of this, it's been leading up to this moment, the climax of the entire investigation. This is the one piece of evidence that seems to tie it all together. You could call it the confession, where completely separate mathematical worlds are about to collide. So on this slide, we're looking at 3 totally distinct mathematical universes. First, you've got the world of primes. That's our number 28,757. Then you've got the binary world, the world of computing. That's represented by 24,576, a number that's all about that binary structure. And finally, you have the world of natural growth, represented by 4,181, which is the 19th number in the famous Fibonacci sequence. And here it is, the confession. 28,757. This number we've been investigating, built from primes, is the exact sum of the binary value and the Fibonacci value. It forms a perfect, undeniable bridge connecting the world of prime numbers, the world of computing, and the world of natural growth. I mean, think about that. This is the kind of equation that, in a purely random universe, just shouldn't exist. Okay, let's step back for a second and review the case file. We've gathered all the evidence. Now it's time to ask for the verdict. So what have we just seen? A truly profound discovery? Or is this just the grandest, most elaborate coincidence of all time? I mean, let's just run through the evidence chain one more time. Our number is built from 2 primes that are themselves linked by the number 7. It sits on the copper index of a cosmic map. It's perfectly, and I mean perfectly, centered between 2 harmonic neighbors. It literally bridges the binary world with the Fibonacci sequence. And, oh yeah, as if that wasn't enough, this exact number also shows up in the real physical world as a specific energy level in molecular spectroscopy. You know, the source material that this whole explainer is based on, it puts it pretty bluntly. The probability that this whole intricate web of connections, from its DNA to its cosmic address to its place in the physical world, the probability that all of that could happen by pure random chance is, and I quote, something that tends against 0. And that brings us right back to where we started, to that central question. Look, you can explain away one weird connection as a coincidence, maybe even 2, but how many is too many? At what point does the sheer weight of the evidence force you to admit that you're not just seeing patterns in the clouds anymore, that you're actually looking at a blueprint? Coincidence has to have a limit. So the question for you is, with the number 28,757, have we finally reached it?